Okay, hi everyone. My name is Dmitry. I'm a senior data engineer. I'm happy to see you all here. And actually, it's my first webinar in Surfalytics, so uh, probably I can be a bit nervous, so it's fine. Also, yeah, I'm going to share the recent task which I got when I applied for one data engineer position in EU. So actually, we can first look at the task, read it together, and then try to implement it. Yeah, so this is this coding challenge. Let's see, consider the following scenario. You're a data engineer for a renewable energy company that operates a farm of wind turbines. The turbines generate power based on wind speed and direction, and their output is measured in megawatts. Your task is to build a data processing pipeline that ingests raw data from the turbines and performs the following operations. Cleans the data. The raw data contains missing values and outliers, which must be removed or imputed. Then calculates summary statistics. For each turbine, calculate the minimum, maximum, and average power output over a given time period. Then identifies anomalies. Identify any turbines that have significantly deviated from their expected power output over the same time period. Anomalies can be defined as turbines whose output is outside of 2 standard deviations from the mean. And then stores the processed data, store the cleaned data and summary statistics in a database for further analysis. Data is provided to you as CSVs, which are appended daily. Due to the way the turbine measurements are set up, each CSV contains data for a group of 5 turbines. Data for a particular turbine which will always be in the same file. E.g., turbine 1 will always be in data group 1 CSV, and so on. Each day, the CSV will be updated with data from the last 24 hours. However, the system is known to sometimes miss entries due to sensor malfunctions. The files provided in the attachment represent a valid set for a month of data recorded from the 15 turbines. Feel free to add remove data from the set provided in order to satisfy the requirements above. Your pipeline should be scalable and testable. Emphasis is based on the clarity and quality of the code and the implementation of the functionality outlined above, and not on the overall design of the application. Your solution should be implemented in Python using any frameworks or libraries that you deem appropriate. Please provide a brief description to your solution design and any assumptions made in your implementation. So this challenge was for data engineer position, and this is for a consulting company which provides consultancies on behalf of Databricks, actually. And this consultancy is kind of providing Databricks consultancy solution, building Databricks applications and Databricks data solutions for the final clients. And that's why I tried to implement this solution for this challenge in Python repo with a wheel, which will be attached to Databricks Workflow and run on Databricks Cluster. And for this, we need Databricks Workspace. It can be created as a trial version. So I've got a Databricks trial. It was for 2 weeks, and actually it's already locked, and that's why I can no longer run anything on this Databricks Workspace, but at least I can show you what I've done in terms of the Python repo and how I've created the workflow in Databricks. I just cannot run this workflow, but apart from that, it should be fine.
Maybe you can, for some people, maybe you can quickly, briefly tell what is Databricks And what's the difference, for example, from Snowflake?
Yeah, so Databricks is a platform where we've got some compute. I mean, in compute we can create some cluster. Like here I've got trial cluster, and for this, in the workspace we may create different notebooks to work with data, and this data could be stored in any cloud, like Amazon Cloud S3, then Azure Cloud, Azure Storage Account, or Google Cloud, and Databricks just refers to this cloud storage, and we can run the code using Databricks Cluster on top of these storage accounts and create the pipelines using the workflow functions. Yeah, apart from that, we also have some serverless SQL. So when we create any tables, save them in the storage, then we can use SQL to just query and analyze data and build the dashboards using Databricks as well. Also, we've got some alerts, for example, if we want to have some data quality and alert on some missing data or something. Okay, and we also have some abilities for machine learning, but I haven't touched it yet because mostly I worked with data engineering and BI part before.
One question: what distinguishes Databricks from Snowflake, for example, if we spoke about that?
I haven't worked with Snowflake a lot yet.
I can tell the difference. So Snowflake, it feels like data warehouse, like Redshift or something like cloud data warehouse. Even if internally it works more like Databricks, it's still built like it feels one whole thing. You load data, you query data, and you have your warehouse or compute clusters where you can run the SQL queries. And then you load data in Snowflake. The data is ingested also in a storage accounts, but the storage account is hidden from you. So it's basically managed by Snowflake. The data is written inside using Snowflake own format, and it automatically save data kind of micro partitions. So you almost not control the process how the data is organized inside. And Databricks, on the other hand, it's the primary thing is just a cluster with Apache Spark, and you can use even open source Apache Spark, and your code will work for most, like probably 95% of everything. And then you're not limited to SQL. You can use PySpark, Scala, I don't even like C#, R, and you can decide in what format you want to save the data and where you want to save the data. So it could be storage account, like S3, and the format could be, for example, Parquet. Or it could be more like Lakehouse with Parquet with like extra like Iceberg or Delta. And then if you don't like Databricks, you can just, okay, I don't want to use Databricks. I want to switch to Trino, or I want to switch to open source Spark. You can do this because the data is in own format, so you can always work with the data independently. In Snowflake, you couldn't switch the Snowflake. It's just you need to extract all the data. It's like vendor lock. But in Databricks, it's more like the data lake in first order. Then you have your cluster with Spark, and then you read data in storage account. You can transform it, and then write back to the storage account. So the Spark, it's just computing environment. In Snowflake, by the way, we have Snowpark that act very similar way like Spark. So you can write your data frame transformations in Snowflake, but again, it will use the Snowflake managed storage.
Mm-hmm.
Thank you.
The
Yeah,
best way to understand, you need to build same project in both systems. Like assuming you have some data sets or like API, you ingest in Snowflake, you do dbt transformations, and you connect the BI, and then you can achieve the same with Databricks, for example, without using dbt. But you can like read data, transform data using PySpark, for example, and then connect BI tool. That's the only
Yeah.
way to understand the difference.
Mm-hmm. Yeah, it's a good point. Thank you. Also, I would say that in Databricks there are two features that we haven't mentioned. One is delta live tables, which is probably similar to dynamic tables in Snowflake. So they are like updated automatically if we set them up. So it's kind of streaming, we can say, with some data quality inside, so we can set up some data quality rules. Pretty useful, but costly. And also there is Unity catalog feature.
Am I right that delta leaf tables, it's a kind like orchestration tools that can produce the DAG, like dependency between jobs, and like in more or less way like how Airflow works or how dbt works, they have the dependency between notebooks or transformations.
As I understand, it's used in the cases when you need to have kind of live updates, but you don't have a lot of transformations. So you just want to get some data from particular table, kind of in kind of streaming way, without transformations. Like get some particular columns with some basic filters. So in this case, you can use delta live tables, and you will get like live updates.
Okay.
Yeah, and also we have a Unity catalog feature in Databricks, which provides pretty useful permission control for your Delta Lake house. Delta Lake, actually. For example, this one is my trial database, and it is based on Amazon S3 storage, and these are schemas created, and inside we've got delta tables. So these are 3 tables which were produced when I've done this coding challenge, and for these delta tables we can manage the permissions based on like in Azure, I know it's called AD groups, but in Amazon probably it's something different, but it's like different groups of organizational accounts. So we can create like a group for analysts, group for marketing, and so on, and manage the permissions in pretty useful way. Yeah, there are some other useful features in Unity catalog, but I think it's more into details. So if someone has any other questions about Databricks, we can discuss them, or we can go directly to the challenge.
If
So
someone
yeah, just about question. This is catalog. It's your internal repository, but it's not Unity, or it's Unity catalog. It is same or different? Catalog, Unity catalog.
It's Unity catalog, yeah.
It is Unity catalog. It is exactly what is Unity catalog, right?
Yes, correct.
Understood.
And you can see that. Yeah, actually, this catalog, it includes also legacy metastore, which is Hive metastore, which was used before in Databricks. But now the most recent feature is Unity Catalog, and this trial thing is already in Unity Catalog organized.
Which storage do you use for your project?
Here I've used S3, Amazon,
S3. Okay.
but you can use any of them.
So it means for this, you have database, information schema. It is database, and under the database, you have data live tables, and the data live tables sourcing flat files from S3, right?
Yeah, so initially I organized it in such a way, so I put these CSV files to S3 bucket, and then using the workflow, I've transformed the data and saved it in another bucket of S3 where I have a Unity catalog enabled, and this turbines schema is created like for these three tables, delta tables, which are saved in Amazon S3 bucket.
Did you use some notebook for this logic, right? And Python for that, right?
Yeah, I've used a Python library, and this is what I was going to show you actually, how I built it.
Okay, yeah, thank you.
Yeah, if I go to the details of the delta table, we can see that it is saved in S3 in a particular bucket in Unity catalog. So it's like Unity catalog enabled for S3 bucket and saved in Delta. Does it make sense? Any other questions? Okay, so if we don't have any other questions, let's go further.
Quick question: if table
yeah.
is managed, can we go to S3 and do anything, or it's not the same as the external table?
We can go to S3 and we can delete the data which is on which this delta table is based.
But
so you
am I right that if we're using Unity catalog, it manages the folder names and locations? So, for example, if you go to storage account, it would be hard to just find the right table, because here you don't have the table name, for example, in your path.
Yeah, so it creates, when we save the delta table, I think it creates in some kind of this format with this naming. So if you go to S3 bucket and you navigate to the Unity catalog in the storage, you will not see the name of the delta table. You will just see this underlying data, if it makes sense.
Okay, yeah,
and
this is the preferable way right now to use Unity catalog, because by default it is using Hive metastore. It's like all the way from Hadoop. But the key idea, you use Spark. You need, if you want to create some kind of SQL tables, and the SQL tables in Spark is just abstraction on top of the data. For example, if you want to connect any BI tool works in the SQL, and they comfortable work with tables. So that's why you need to have catalog. It's the same catalog if you use Glue or Fina. It's like your basically list of the tables and schema. This is your catalog, and you by default Spark use Hive metastore. But Unity catalog is like better. So it gives you many features. For example, you can control access to the tables. Maybe you can do row level access, more like enterprise data warehouse.
Yeah. Yeah, also you
So
can.
that is a lake house. That is what we call lake house.
Mhm.
Yeah,
Yeah,
it is Lakehouse, yes.
yeah, and as these are like in delta tables, in Unity Catalog there is a feature also to track the history. So if you go to history here, you'll need to select compute, and then you will see the like delta logs for this particular table with the changes, like when were some recent changes done for this particular delta table. Yeah. Also, it has some lineage insights, and you can also have some data quality, but I haven't used it yet. Probably it's something new. Okay.
Where we can copy the code that you have an example.
Yeah, it's in this repository.
Can you share a link in the chat, please?
Sure. I can also share the files.
Yeah, the file you can upload as well.
But how can I upload them?
You can upload in Discord.
Okay.
Maybe you go to data engineering project. Oh, it's here as well. Yeah, and click on the right corner. The chat option.
Okay. Yeah.
And yeah.
Is it already attached in the chat or not yet? Oh, no, it is. Yeah. Can you now see it?
Yeah, we have it.
Okay. So how shall we proceed? Shall I go through the code to explain what has been done?
Yes, maybe
Yes.
how would you do it in Databricks, and then we can repeat.
Mm-hmm. Yeah. So if I take a look on the repo, so how I usually did it on the recent projects and the way we worked with Databricks on the recent projects. So we have Python repo where we have the pipeline. So in SRC, I have the code, Python code with different modules. And I have a main module which has the entry point, and then I have the setup file with the entry point. This refers to this main Python module in pipeline folder, and then we build Python wheel. Usually it is built during CI/CD pipeline. So the CI/CD pipeline runs and builds a Python wheel, and it saves somewhere in the storage, and then in Databricks we just refer to this Python wheel. For this project, I did the build manually in the repo using a command, and then there is a dist folder created with a wheel file, and then I go to Databricks, and Databricks is connected with my repository. So if I go to the workspace, we can see that there is a repository set up. So this is my user. And
do we need to set up repository ourselves?
Yeah, so actually when the trial account is set up, we set up the storage we work with. Like in my case, it was Amazon S3. And we also set up the Git repository. So if we click on the repo, we can see that we can pull data from the repository from GitHub, and we can also push changes that we do directly in the workspace in Databricks. For example, if we create the notebook, we can also see this notebook here and push it to our repo in GitHub. Yeah, so when we develop the project locally in Python, for example, like here, I develop it in VS Code. So I built all the modules, and yeah, the requirement for the task was to build the pipeline which is scalable and testable. And for me, scalable and testable means that for testable, we have PyTests, or tests, which can be built in PyTest. And scalable means that we have kind of the Python repo, Python wheel, where we can reuse different parts of the code using the object-oriented programming. Yeah, and then once we build the pipeline using Python and object-oriented programming, we build the wheel, which is saved here in the dist folder with the wheel format. Then we push our code to the repo, and when Databricks refers to this repo, we can attach this wheel to the cluster to run the entry point. And then we go to the workflows. And in workflows, we can create a new job, which will be run on the cluster. So this is the job I've created. In the tasks, we can create the tasks. And this job contains just one task, which will run the entry point. You can see that the task can be of different types. It can be a notebook, which is created in the workspace. This is like a notebook, which can be written in Python or Scala or Java or something else. Some Python script, SQL. It can be also Delta Live Tables pipeline, DBT, jar, Spark Submit, and some other options to build some dependencies between the tasks. And in my case, it is Python wheel. So I select this type, and then I choose the package name. this is the name of the package which is in my wheel actually, and the entry point, which is also, it comes from the setup file in my Python wheel. Then we need to select the cluster. The most cost-effective one is job cluster. So we can use this. And then we select the dependent libraries. So this is the library which comes from my repository. As you can see, it refers to workspace, users, my name, then the project, dist folder, and wheel file from that dist folder. And we can also attach different parameters to the job. In my case, it is start date and end date. And in my code, I'm filtering the files, the raw files, to get the dates based on the parameters from the pipeline. So in this case, every day, so we can trigger this job. It will run like kind of every day on particular time, and it will pass the parameters based on the date and filter the raw data and limit it to the date of the run. Yeah, and once this task is created and the job runs, it refers to the wheel file and it gets the package name from this file and runs the entry point. And the entry point, in my case, it is so here it is main file. We go to src, pipeline, main, and here I have the Python code. And in main, I'm parsing the parameters, start date and end date, from the Databricks pipeline, from the workflow. Then I'm initiating the Spark session, and then I'm loading raw data, processing it, and write the clean data to the output. Then I also write the anomalies file and the statistics file as was requested in the coding challenge. And for these functions, I have also separate Python modules. Yeah, let's start from the beginning. We have the load data.
Can you speak about where did you write the Python? Inside, like, did you open just Databricks notebook, or you write the locally? For example, I see that you importing the PySpark session, but if you're running everything on Databricks, should it have Spark session by default?
Yeah, I've built it locally.
Or even not using the Databricks, just local Spark?
Yes. Yeah, just local development in VS Code. Yeah, also I've created the tests and could test the functions. And then when I kind of know that it's ready, also in the meanwhile, I can test some of the functions in Databricks notebooks if needed. So when the pipeline is ready, I just build the wheel also locally, and then I push everything to the repo. Databricks is connected to the repo, and then I create the Databricks workflow in Databricks, this one, and I just run this workflow in Databricks, and it produces the output in the Unity catalog. Yeah, also what we usually do if we want to set up CI/CD pipeline and also automate the creation of workflows, we can switch to code version and can see the YAML file of the workflow. And we can also copy it and attach it to our repository. So in our case, in the jobs, for example, in the jobs folder, we can create our workflows. And then in my case, I didn't use any CI/CD pipeline, but actually we can also build it. And the Databricks workflow will be deployed to the Databricks workspace using CI/CD pipeline. It could be either YAML file in Azure pipelines, so this one I usually use, but I don't know which is used in Amazon, but I'm pretty sure that it's also possible with any CI/CD tool from Amazon. Yeah. As you can see in the code of the workflow, we can have all these settings that I have explained previously, like the name of the job, create the task, select the type of the task, like the name of the task, then it's Python will task which package name and entry point for this will. Then we select that it's a job cluster, and it will create this job cluster with configurations.
Is this Databricks jobs that was created by Databricks, this YAML file, or you need to create it manually?
Yeah, so usually you just first you go to Databricks, and in this UI, in the visual mode, you can create a workflow using UI and these settings from here. It's just easier, right? So you create it first here, then you switch to the YAML format. You just copy it. Actually, not YAML, I think it was JSON. Let me check. No, it's YAML. Okay, yeah. And you copy it from YAML, and then you copy it to your repository. You may have some additional settings according to the will, like probably when you set up the CI/CD pipeline, you will have a will in some other place in your storage or something. So you will need to set it up. But apart from that, it's pretty much it. And in CI/CD pipeline, you need to provide some settings to deploy the workflow to the Databricks. Does it make sense?
Yeah. And can you run this? This is for internal, for Databricks, right? Not for like GitHub CI/CD.
I think that I think it just depends on the platform you're using. Like if you're using Amazon, then you will build the CI/CD pipeline using some Amazon stuff, Amazon tools. Then if you're using Azure, you will use CI/CD and YAML file and just deploy it using Azure pipelines. Probably you can do it also using GitHub, but I don't know. Haven't used it before. Does it answer your question?
Yes, thank you.
Yeah. Okay. So, yeah, shall we go through the code to take a look on the functions? What do you think?
I was
Could you please
thinking,
just,
oh,
just first of all, I see the scripts, and I don't know if I'm only who experiences these scary feelings about all these functions, what is written there. Could you please describe your approach, how you write these functions in these notebooks? Do you make it as a team? Do you take it as a template from any place, and you build it like from some bricks, or you write it from the scratch? How you approach this notebook? Please share.
Yeah, sure. Yeah, so initially, I'm just thinking maybe I can create a new new branch and just develop it from scratch. What do you think? If we have time.
No, not right now. I'm just speaking generally. So you are writing it from the scratch. Okay.
Mm-hmm. Yeah. Yeah. So if I write it from the scratch, it's just from my experience, right? So usually in a Python project, we have like SRC where we have the source code, and inside of, so I've created the source folder, and inside of source folder, I've created pipeline folder where I have the main Python scripts, and I have also configs. So in the configs, yeah, let's just start from the beginning. Init file, it's just it's empty and it's used to initialize the module. Then we have the config file where I have the configs, some specific namings, right? Like database name, which is used in Unity catalog. It's my trial database name. Then schema name, which is turbines, and it refers to the, it's like project specific. Then I have the raw data path, and in this case, it is stored in workspace, in Databricks workspace, in shared folder data, and then we have these CSV files that are, which are in the task. So these 3 CSVs. Let's just open them to understand them a bit better. So in CSVs, we have timestamp, turbine ID, wind speed, wind direction, and power output. So characteristics of the wind turbines based on the timestamps. So they are stored in workspace. They could be stored in S3, but just to save the cost, I put it in the Databricks workspace in shared folder. It was there. It's a raw data path, and this path is later used in load data step. Then these are the names of the delta tables. So in the task, I need to save 3 tables, one for cleaned, one for statistics, one for anomalies. So these are the names of the delta tables. Yeah, actually, they could be directly hard-coded in the Python functions, but this is just the way I'm used to work with Python, right? To have some configs and then to refer these configs in the code. And later, if, for example, something changes in business requirements and the name of the table should be changed to something, then we just change it in one place in configs, and we don't care about the rest of the code we have. So this is about configs. And then the first part is to load data. For loading data, I've created a Python function. So it's just loading data to a data frame, and it uses Spark to read CSV files. CSV files have header, infer schema, and then we have this file path, which comes from the argument of the function. And we have also start date and end date, and we filter these CSVs based on these dates. So it's like we load all the CSVs from the path, so we don't have to union. When we write it like this, we just load all the CSVs. So we assume that they have the same schema, and then we filter them based on the start date and end date. And as I showed previously in the main file, when I use this load data function, as you can see, load data function is it is imported from load data module. So this from dot load data means that from this load data file, we import this load data Python function, and we include these parameters, arguments for the function. First, it's raw data path, and raw data path comes from config file, which is here. And then we have start date and end date. And start date and end date we have as arguments from the Databricks workflow. And to parse these arguments, we are using a bit of code here. I think I just used ChatGPT to come up with this several lines of code. So this is about loading the data. It loads the raw data in CSV files to a data frame. And after that, we need to process data. For this, we have another function and another Python module. This process data. It's a medium, like pretty big one. And we, as you can see, we have used PySpark SQL here. Okay, and the main function here is process data. It pre-processes turbine data to prepare it for anomaly detections. So it fills missing rows with the mean value for each turbine an hour, and it also computes z-scores for the data to standardize values. And there are also several functions inside of this process data function. I don't write all the code here in this function, but I split it into several other functions, so it's so that this one is not too complex and I can test each part separately, and also it's like better visibility and understandability of the code. So the first one is to get all timestamps. So this one just generate a data frame with hourly timestamps between two dates. So as you remember, we have start date and end date, and first we need to generate this data frame so that if so we have the CSV files with timestamps, right? But we don't know if there are all timestamps or not. So first we need to generate this data frame with all timestamps between two dates. And then we can compare this data frame with timestamps that we get in CSVs and see if we have some missing timestamps. Then we fill them with some mean values. So it's just some cleansing. Yeah, so I've created this function to generate the timestamps data frame. Then I impute missing values with mean values. So for example, if yeah, so here I use the cross join to get the values for every timestamp. I get the values from turbines. Turbines, it's like the CSVs, and then I see if I have some missing values, then I replace it with the mean values, which I calculate here. So this is some PySpark to calculate hourly means. As you can see, I group by turbine ID and hour, and I generate mean values for wind speed, wind direction, power output, and then I join the existing data frame with this mean data frame, and then I'm using the coalesce, and it means that for timestamps where we don't have any particular value, if we use coalesce between the actual value and the mean value, in like any way we will get some value. In the rows where we get the actual value, we'll get the actual value. If we don't have the actual value, then we get the mean value for this row. So this is kind of cleansing for our raw data. And then I'm also calculating z-score.
What I can tell you from the code I see, you don't use best practices for PySpark in terms of how to write the code like simple linting. I will share one link that usually very helpful every time when you work with PySpark.
Okay, yeah, sure, it could be helpful. Yeah, I can't say that this is like the perfect code. I just I'm just explaining how I've built the repo, right, and how I approach this particular task.
Yeah, I just shared the style guide.
Mm-hmm. And what exactly, like?
No, it's very minor. Like, for example, when you import the functions, you call like f dot. You know, like there are some other examples.
Okay.
Like they not impact how the code work, more like
Yeah, sure.
how they read the code.
So using F, it's like the best practice, right?
Yeah, it's just one example I remember.
Okay.
But it's good, bring this thing on the interviews, like, like sharing this link with the
Yeah.
style guide and so on.
Mm-hmm. Yeah, of course. Okay, thank you. Yeah, so as for this data processing, I'm replacing the empty values with mean values. Then I'm calculating z-score for speed, direction, and power output. And this z-score is used to determine the outliers. So usually when we're dealing with some outliers, we assume that the outlier is a value which is greater than 3 standard deviations from mean. And in this function, I'm replacing these outliers with the mean value. it's just the requirement from the task. And yeah, actually, in some cases, I think it's pretty useful when you're taking a look on some statistics, because some outliers can be pretty big or small, and it can affect the statistics when you're doing some aggregations. Like when you need to provide some data to management, for example, and you're doing aggregations, some outliers can affect this. Okay. Yeah. Do you have any questions on the processing?
No, I think, yeah, it's straightforward.
Okay, cool.
I noticed in your repo, like .vs code folder, did you create
Yeah,
it? Did you create it, or it was automatically added?
it was automatically created when I set up the PyTest. So as you can see, there is like one value for it refers to Python testing. And when I was setting up the testing testing extension, I guess, in the VS Code, I set it to use the SRC. So it looks for test files in SRC folder. So as SRC is like the source code folder, I'm checking only this one, and it appears in this settings.json of VS Code. And apart from that, as I'm using PyTest, it also sets PyTest enabled to true and unit test enabled to false. But it was done automatically, right?
Okay.
Yeah, apart from the VS Code file, I also used Flake 8 for linting, like as a standard. And I also put some settings here, like to exclude some files. We don't need to take a look on Git files, then build, because this like build documentation, which is automatically, and also the dist folder, which is also coming from the build of the wheel, and it is created automatically. And I set to ignore E501, which is the error about the length of the row. Like, I don't know, if we go here, for example, most probably this line will be highlighted because it's like pretty long, but it doesn't make much sense to me, and I just disabled this function, this check.
How do you actually build the, okay, for example, you want to build the wheel, right? You have the code that can read.
Yeah.
What is, can you show one more time, what's inside init.py?
Here, just nothing.
Okay, just
in
requirements to
all of
build
them.
the package. And the config.py,
Yeah.
you put some variables? Oh.
Yeah, in config.py, it's just some variables, naming for the database, schema, and the tables, and the raw data path.
Okay, and how do you build did you build it locally, or
Yeah.
Databricks can build it as well? Or Databricks only required wheel that you built locally?
No, it's not like that. I think you can also, you can just have the repo with a setup file, and then in your CI/CD pipeline, like YAML pipeline, YAML file, you can also include the commands to build the wheel during the CI/CD process. So you don't need to do it locally, but it's just in my case, as I don't have the CI/CD set up, I do it locally and deploy it manually. but usually it's done through CI/CD pipelines.
Mhm.
So in order to build the wheel, you need to have the setup file. In this setup.py, so we importing the setup tools. Then this is kind of the settings for the package. So this has the name for the project, the version. So usually you keep the version in because just when you deploy the wheel, you need to see which version of the file you deploy because it can change, and yeah, some changes cannot be in the previous version and so on. So it's useful. Then packages, it needs to find a package in my case, it's in SRC folder, and package dir is SRC. Yeah, as you can see here, I have some installation requirements for PySpark and Delta. And then we have this entry point. Here, you just write the name of the entry point. And here in this part, you have the path to the entry point. So it looks inside of SRC folder to find the package directory. And then in SRC folder, it looks for pipeline, which is this folder, then main folder, which is main file, which is this one, and then main entry point. So if we go to main file in pipeline folder, we can see that we have main entry point, which is this one. So configuring this setup file, we configure the package, and then if we build this locally, we need to write the command in terminal to build the package. So for this, yeah, it's pretty straightforward. If you just Google it, you will find it. But in terminal, you click this, you run the command Python setup py. So setup py is the name of our setup file. It could be different, but usually it's like this. And then build distribution wheel. So we run this, and it updates the wheel file, as you can see here. So it provides the name from this project, wind turbines project. Then it comes with the version, which is specified here. And yeah, then just .wheel. It also creates some other folders, probably like this one, but usually they're not used. So this is the main file which we need to use when we create the workflow with the wheel task. Does it make sense?
For example, I never built this before, so it is, yeah, definitely not that easy. But can you repeat the egg file? Because I know in Python you can build egg or wheel. It's like two different things. Or it's, and then I see in your case I have egg.
Actually, I've never used egg. Just I don't know what's inside. So here we have some egg info. Probably these are some settings for egg. You see we have, it's created automatically. And you see we have like entry point settings, which is exactly the one which I'm using. Dependencies, some package info. So just some settings probably for the egg, but I haven't used them. So this is the main file which is needed for Python wheel. Yeah, so it's like you create the Python modules, and usually there is the main Python module which will run all your code, and it's in main file. There is also this part. If name equals to main, then it runs main.
No,
and,
this is clear. What's the code you use to build their package? What command, I mean?
Yeah, so it's this one. Python setup py-bdist-will.
And bdist-will, is it command or then just the name for the package?
It's the command. The name is setup
inside.
py. It's just the name of the Python file.
Why
so
you
it's
don't
like
use you don't use any plugin for shell? I mean, it's like default terminal for Mac. In CLI. No, I mean, it's just a random question. Like, it's just default terminal on Mac, right? You don't use this shell, for example. You know, then you have nice, like, different colors of the path and some, like, are you in GitHub or not, like, and those kind of things.
I don't know. Just,
yeah. It's way more enjoyable than you. Yeah, you can check all my Z shell and all my Z shell. So it has lots of like ways how to do it. In the model 0 of Surfalytics, I showed some examples how to set up and how it works.
Okay, thanks. I'll take a look. Yeah.
Yeah, I think overall using wheel for Spark, it looks a bit weird for me. I don't know. Because if you want to run Spark, you can run Spark submit, like create the Spark job, and then just Spark submit. It will run. Yeah, I don't think it gonna run on Databricks specifically, because it feels like you treat it as a Python package, and then you just execute the Python package using Databricks Cluster, but it could be just any Linux virtual machine where you can just install PySpark if it has PySpark library, or you can just have a kind of, I don't know, poetry or virtual environment, just install all libraries and just run your Python code. And the question, it is not clear for me how it's gonna work for if you have like, I don't know, 100 gigabytes of data to process. How it will use the wheel package to redistribute everything.
To redistribute everything.
I mean data.
On
if
the
you
cluster,
have lots,
you mean?
yeah, how the cluster will work if these. I don't know.
But it depends only on your code, like what you run in your code. Like you can use some multi-threading or something else.
But did you use this wheel ever in production?
Yeah, for sure. I mean, in
Databricks?
Yes, in most of the projects of the recent projects, like 1, 2, 3. So in the companies which tend to use Databricks, so they usually build the Python repo and then Python repo with the jobs, and then run these jobs in Databricks Workflows, and usually it's using the wheel. Yeah, but it was in my experience. Probably it can be different, and if we take a look on the job settings, we may have also, apart from Python wheel, we can use Spark Submit. It's just I haven't used it previously.
But did they ask specifically to use wheel?
It's just how our projects were set up.
No, but I mean in interview, did they ask use wheel?
No.
Because for me it looks, if I would ask someone to use Databricks and then they send me the wheel package, I would say no to this candidate. I mean, because if you're using Databricks, why you need all those complicated? There should be an easier way to do this.
Hmm.
It's
think
just
it depends.
my opinion, yeah. But I'm very biased towards those like enterprise solutions like Snowflake, Databricks, where you're actually avoiding all this like open source mess.
But did you use Databricks in any production projects?
Yes. In Microsoft, I've implemented it from scratch for Xbox, and we had before HD Insight and Hive for staging, and for fact tables we use on-premise SQL Server and integration service. So my goal was it was 2021. My goal was to build, or maybe 2020 even. My goal was to build Lakehouse, like replace this kind of split environment between SQL Server and HD Insight Hive into single Databricks environment using Medallion architecture and Delta Lakehouse. Yeah, it almost 2 years I was doing this thing. But
Yeah, and
but
how did you
also,
build the workflows?
so then you work with Databricks, you rely on notebooks.
Yeah.
So you can think about this, one notebook is equivalent of one DBT model, right? So, and then you, instead of having DBT models, you have a bunch of notebooks. And then for every table, like for example, you have the O notebook. For every layer, like with bronze, silver, gold, you have tables there and you have O notebooks. And then you orchestrate them using, for example, we use Data Factory, but you can use, I think you can use DLT here inside. And you can also use the PyTest, you can use Git integrations. But the thing is, everything was as a notebooks, and it was actually downside, and I think it's still downside of Databricks. It's not friendly with IDEs, and it's kind of let you use notebooks for your development environment in the browser.
Yeah, I would say that using notebooks is very old school for Databricks, and I also started using Databricks with notebooks and Data Factory like about 6 years ago. But the thing is that with notebooks, it's not scalable and it's not controlled, I would say. It's like in every notebook you have a lot of repeated code, right? Or
No, it's you can still have the same thing. You can have the blocks and models, so you can have like system notebooks with all your functions, and then other notebooks will call it. But first, it means you need to execute those notebook and load in cluster the code from them, and it's the same as you have other files with Python, but this is basically other notebooks.
Yes. Yeah.
On the most recent project, how did you use the Databricks?
Yeah, it's the way I described it with the use of Python project with the wheel.
Yeah, but you basically develop everything like on your local machine, package, and then you only use Databricks for clusters, like to compute.
Yeah, and there is also Databricks Connect library, Python library, which you can install in your terminal, in your local machine. So it's like you install Databricks Connect, you set it to connect to your Databricks workspace, and then you can run the code, your local code, using the compute from your Databricks workspace. So in this case, and not only compute, but also the data from Databricks workspace, which is referring to your storage. So in this case, it provides a lot of flexibility in terms of local testing. So you can develop everything locally, and you test it using the real data and the real compute. And then you just deploy the code, and that's it. And you don't need any notebooks, any repeated code. So everything is within your Python project, and it's testable and scalable.
And okay,
good.
no, it makes sense because this is, yeah, it's interesting to know opinion of Databricks itself, right? What's their best practices? Because then you do the Databricks trainings, they teach you how to, use their functionality with like notebooks.
Yeah.
For example, why I did in this way? Because I didn't know any other ways, and then I finished all kind of Databricks trainings about data engineer specialization or building data lakehouse. Everything they do, they using the notebooks. The way that's, I assume it's their preferable way, but then there is people coming from, I don't know, Hadoop experience, how they manage this in the past as a Python package, and I see lots of benefits in this, except like it's more complicated, but you have your local environment, you can test it locally, you have all the dependency and so on and so on.
Yeah, it looks more complicated at first, but in reality, it provides a lot of benefits. Like it's easier to support. It's good for maintainability, for testing the code. So everything is testable, scalable, easy to scale because you have all the functions in your repo, and when you need to set up the new pipeline with some new data set, you can reuse your code from the repo, just add some additional settings as for the raw data and output. This is the good thing. And also, I feel like, so the notebooks, they work on the, how is it called, in the compute. So if you go to compute, you have all-purpose compute and you have job compute. So for all-purpose compute is usually more expensive, and job compute is the least expensive. And
what's the difference between them? I heard about that, like in common words. What's the difference between them? All-purpose and job compute.
The difference is like all-purpose compute is usually used for ad hoc analytics, and when you create the notebook, so the only way you can run the code in the notebook is usually using the all-purpose compute. It's fast to analyze the data, so you just create the compute, you create a notebook, attach compute to the notebook, and then you do some ad hoc analysis. So you take a look at the data, just to see what's inside and do some basic analysis. And you can also test your local code there if you want. But when you schedule the jobs and you have some workflow which is scheduled to run on a daily basis, you can use the job compute to as the least expensive to run on a daily basis and to not consume a lot of money, right? So job compute is for jobs which run regularly.
Understood. Understood.
And the bad practice is when you create the workflow and you attach all-purpose compute to the workflow, then it runs on a daily basis and consumes a lot of money.
One question. We have workflows and we have jobs. What's the correlation between them? One workflow can include several jobs, or how it connect with each other?
Actually, it's a bit messed up, as I understand.
Yes.
So this section is called workflows, and inside we have jobs. So it's like we create a job, but yeah, actually, I don't know. For me, it's all jobs.
Yeah, it's the
but
same.
it's called workflows.
But I think it calls also workflows because here you have delta leaf tables. So, and it's probably then you can orchestrate, you can see, you can create pipeline. And then I think pipeline, you can run like multiple jobs in order, like your ETL.
Yeah, it's like you can have the job from here, and on top of that, you may have delta live tables, and all in all, it will be workflow or pipeline.
Pipeline. We have no pipelines in Databricks. We have pipelines in Azure Data Factory.
But here it's also called pipeline.
It's also called pipeline.
Yeah,
I see.
It's like a pipeline for delta live tables.
Okay. As to me, I also have Databricks, and my project on Databricks also connected with repository on Git. So it's done this way, like shown in current example. But previously, let's say 5 years ago, I used it was project with Databricks as a notebooks, which were called from Azure Data Factory, pipelines in Azure Data Factory. So both implementation I passed. Yeah.
Yeah, for me also, when I started to work with Databricks, it was in Azure environment. So we created ADF pipelines and we just called Databricks notebooks from there. Probably at that point of time, there were no jobs in Databricks, but I'm not sure about it. But now the best practice is, yes, to create workflows here and also to connect with Git. Yeah, there is also ability to call Databricks workflow from Data Factory pipeline if needed. For example, if you have some data ingestion to ingest some data from, let's say, SQL Server to Azure storage account, you may use some Data Factory copy data activity. And then if you need to immediately start some Databricks transformations to create some delta tables as output, you may include workflow, Databricks workflow in the same Data Factory pipeline to run it immediately after data ingestion. And then you will have your data transformations and output it in Delta, let's say.
One question while I was speaking about Databricks. Did you work with Azure Databricks Asset Bundle?
Not yet.
Not yet. Mm-hmm. It's just another way of launching your pipelines, another way of launching pipelines. Yeah, and we have such implementation at work currently, but I also somehow launched it, but didn't completely understood it. That's why I asked about that. How to put this piece on the whole roadmap? What you have?
Mm.
Yeah,
can you provide any details for what is it used?
Maybe link. What's the name? I can try to Google it.
Asset bundles.
Databricks Asset Bundle, DAB. Databricks Asset Bundle.
Yeah, they have the link. Yeah, if you Google, you will find it. I shared the link in the chat. Yeah, it's adoption of software engineering best practices. That sounds like a similar idea what we did today. And like, yeah, I think it's very good. I think that's what I was missing in the past. Dmitry, can you open the link? Like, just show the picture.
I don't know.
It looks like containers. It reminds me containers approach in Databricks. I don't know if it is.
From the picture, I think the main idea that you can locally running and manage environments. But what's the bundle? What's inside the bundle? It's a good question.
Mm-hmm.
But I think it should be a similar way what we did today, but maybe it's not wheel, something else.
Yeah, maybe.
But just if you look on the picture, you have this local environment, right? There you have the project, and then you deploy, and you deploy only in dev, and then you have CI/CD process that will running in stage, and then deploy in production if you approve. So I think this is like what's the actual any kind of data engineering project should look like. Doesn't matter like Snowflake with DBT or some other. This is your ideal state of the project. Then you can have this kind. How you will achieve this? This is the big question.
Yeah, it's interesting. Yeah, definitely I need to know more about it.
Yeah. Stas, maybe you need to run the project for us next time on the bundle. Just show the demo.
Yes, definitely. Let me grab something from what I have at work. I don't want to promise, but okay, I know that I understood that we have such requirements. Let me just collect
That's
it.
the only way for you to learn this thing.
Exactly, it's opportunity. Yeah.
Okay, but I think it was very great discussions today about like
Absolutely.
Databricks and how we running it in production, all those
It
things.
looks like blueprint. It looks like blueprint, so we can refer to this session for any project.
Yes, and I think for people who learning as a data engineers, and because today example, it's actually intersections of both. It's not only Spark, then you read and transform the data, but you actually focusing on the Python development itself. So you have a bunch of Python files, you organize them in the right way. You have the setup.py to build the package, and then you can run the package. Dmitry, do you know how can we run the package locally? So, example, I have this wheel. If assuming I don't have Databricks, what would be my next step?
I think we need to Google it. I haven't done it before. I know that it's possible in Databricks using some commands. Let's just take a look on them briefly. If I go to my report, I had it in the notebook. I just this is how I tried to run the wheel. So as you see in the notebook, I've specified the wheel path, and then I did pip show just it's to check if the package is installed. So yeah, I specify the wheel path, then I do pip install this path with the wheel, and it should be installed on the cluster. And then it should be done using sub-process. So it's like you select sub-process from the package and you run it. In my case, the sub-process is called run pipeline. It's it's defined in setup.py file. And I also need these parameters. And then I just tried to do something using actually it should create, it should run the whole sub process and provide the output as creating the delta tables.
How long it took for you to build this?
Around 3 days, I guess, something like that.
And how much did you use ChatGPT?
I used it for some functions. Yeah, like for some basic Python functions, I think I've used it. And then just I tried to organize it in a better way and provide some better descriptions and so on. And also I used it for tests, I guess. Yeah, it's a good thing, like when you're building your Python project, to have the tests. It's good to have the coverage of your code above like 85%. The coverage is the percent of the code covered by your tests. And ideally, the tests should cover all your functions, Python functions. So in this case, for example, I'm using PyTest, and I'm testing like load data, as you can see. And there is also the extension in VS Code. It makes the testing pretty, how to say, not straightforward, because it's still complex, but it's just easier to run the test and see the results. So for example, you click this run. So it identifies the tests and it provides these buttons for the tests. And then you click on the buttons and you can run the particular test and see if it's passed or not. I don't know if you covered PyTests in Surfalytics before.
No, because I had one project in mind with GlueSpark. Then I used the PyTest to like similar way to on the assertion and the mock data, but we didn't yet there. So we mostly spending time on still like Snowflake, DBT, some BI tools. So we're not there yet. But yeah, that's the PyTest is probably the only way, or probably the best way to running the tests. I know you for Spark you can use DQ library.
Data quality.
Yeah. It's if you Google DEEQ UE library, then it's probably like great expectations specifically for Spark.
But it's for setting up the data quality, right? It's different from unit tests. So you check the quality of the data, and in this case, with the unit tests, you test the quality of your code and your functions. So they are like separate, and both of them are.
Yeah, and I think it's very important because here you focusing on quality of the functions itself, right? So you like that, but you can also do the test on the quality itself, like the data that's coming from in your pipeline just makes sense. Also, the project we work like with Cebek is to you have your pipeline that's running every hour, and at the end of your pipeline, like you run in other little jobs in Databricks or like in Glue, and they write to AWS CloudWatch metrics. So they basically how many rows you loaded in partition, how many unique users break by some kind of like dimensions, and you every hour you write into CloudWatch, and CloudWatch allow you, and it's basically line charts inside CloudWatch. You can create alarm if threshold is broken. Alarm will you connect like SQS, I think, topic, and it can send you SMS, it can call you, or you can connect with PagerDuty. So it's like traditional, this incident management approach. But it means then you're loading your jobs. After you finish load of the jobs, you can run in other jobs that will collect metadata about data you just loaded. Or maybe you can do it, for example, I usually do it right in the same time then I loading. So it's the same pipeline. So it's loading data, and then I write some kind of metadata, how many records I process, how many like unique events and so on. And this can help you to monitor for your data.
Yeah, also useful. But yeah, I can say that unit tests are also essential when you work with a Python project. So it's always very useful to have tests covering your Python functions. I can briefly cover what we have in the tests and how we can use it. So we import PyTest package, and then to create a test, usually we have some arrange. It's like some sample data, let's say, and then here is act where we run our function, and after we run the function, we do the assert to check if the behavior of this function is as expected. And here, when we would like to run all the tests in our Python project, we can run PyTest in terminal, and it will run the test session and collect all the items. It actually, as we saw in this settings, we have some settings for the Python testing. In my case, it will go to src folder. So it's going to src folder and finds the files with test underscore. So it finds this file, and in the file, it finds the functions with the tests. So it collected 3 tests, as you can see here, and as all of them passed, it provides these 3 green dots. Like you may have 10 tests, for example, and 5 of them will be green and 5 will be red because they will not pass, and you will need to work more on them in order to pass. Yeah, it's like kind of brief explanation of the unit test here.
And do you have any specific commands to run PyTest? Like
yeah, this one.
But I mean, in your pipeline, how you expect to run it? Is it another job? For example, in Databricks, you schedule your job, but who running PyTest in Databricks?
Yeah, usually it should be also in CI/CD pipeline. So when you deploy, when you run the CI/CD pipeline, you run PyTest and you see the code coverage and also the results of the tests, if they passed or not. And after that, you deploy the Python package. And you can also do some settings in the CI/CD pipeline, like if the PyTest didn't pass, you may stop the pipeline and notify the developer to do some changes in the Python package so that the unit tests will run successfully.
Okay. Yeah, I think it was very good session.
I have a few questions. Hi, everyone.
Hello.
Hello, do you hear me?
Yes, we can hear you.
Hi, everyone. Dmitry, I have a few questions to you. You told that this Python will make your project scalable, reusable. If I get this, you mean if you add some new functions, some new logic, you can reuse the existing functions. Can you reuse this function in another project, like refer to this Python will from another project, another Python will?
So the way you usually, so what I mean by scalable and code reusability in this case is like, for example, we have this Python project within our data engineering department, right? And I worked on this part with wind turbines project, let's say, and you are working on the project with something different, like, I don't know, something about marketing. So you have some marketing project. So in this case, we will have kind of different pipelines in our repository. So we may have like one project for wind turbines where I will put like for example, these files. And then we'll have, not here, but here we will have some pipelines for marketing, where you will create also some Python functions specific to marketing, but we will use some common functions. So we will use the common configs, for example. You will add some rows specific to marketing here. Like this. Then you will, so this main is related to wind turbines.
Is there any screen share here?
Sorry?
Is there any screen share here? Is it not visible on my phone only?
Yeah, there is a screen share.
Yeah.
I can see everything.
Do you see my VS Code?
Maybe from I don't see.
Yeah, I see.
I'll connect to the computer. From the phone I don't see, but that's fine.
But I have the record, so right after I will upload on YouTube and share in Discord.
Mm-hmm. Yeah, so the thing is that we may have separate folders for separate jobs, for separate pipelines, domain specific, for example. And we will have also some common files where we keep the configs and we keep the common functions like loading data, writing data, testing data, sounds like that. And we will have the entry points for various pipelines in the setup file. So currently in the setup, I have only one entry point related to my pipeline, but we may have various entry points, and depending on the workflow, we can execute different entry points related to different business domains. But we will have all the pipelines in one code repo in one Python project, and it will run the same unit tests, and they will reuse some common Python functions developed by our department. So I think it's pretty useful.
Oh, got it. So it will be one project for the whole company, and there will be some folders refer to each department: marketing, I don't know, finance, and something else.
Mm-hmm. Separate
And
folders
you can,
related to different pipelines.
Using these entry points, you can manage the pipeline in Databricks. Which exactly pipeline you want to run, like pipeline for marketing or pipeline for finance? That's correct?
Yes, correct. Correct.
It's not obligatory. It's not obligatory. It depends on size of company. So you can divide it different way. And usually under one department, you have data engineering department, you have different projects, and for each project you have separate repository. Like project, I mean business project, like initiative, business initiative, and you have separate repository specifically for this business initiative.
Yeah, but actually it depends on the company. It can be different in different companies. Like it could, in some small company, it can be one repo for for all the projects, or in some companies it could be one repo for one particular business domain specific engineering team. If we have several engineering teams related to several business domains, for example.
Okay, thank you. How do you test your code locally in a real project when you have all your data in Databricks in Unity catalog? How do you test it? How do you connect from your local VS Code to Databricks?
Yeah, so there is, if you see my screen.
Yeah, I see.
There is a Databricks Connect library. I meant it briefly previously in discussion with Dmitry. So you can install it on your local machine in your local virtual environment. And you can set it up to connect to your Databricks workspace. And it will use the compute from your workspace, and it will also refer to Unity catalog tables from your workspace. And this is how, yeah, actually, I think it's the best way to test the local code locally. But also it's possible to take out some parts of the code and just run it in notebooks.
Yeah, okay, got it. You can point out using the Databricks Connect which cluster you want to use. Yeah, like for example, you have 5 general clusters, one for dev test, and you can point out.
It's better to use the VS Code extension for Databricks. Now it's pretty mature. There's slightly difference with Databricks Connect how you do it, but I guess it's a topic for separate could be discussion. From Databricks VS Code extension, you can actually use different clusters. I think you cannot use the Databricks serverless, but that's where the Databricks Connect would be helpful by itself. So you can run a lot of things right now with Databricks extension. You can run pipeline, submit PySpark commands, you can select the cluster. So really, the local development now is much fun than it used to be.
Wow, that's really useful point.
Yeah, thank you.
Turkey, why you aren't join Teams?
Well, I'm just taking care of my daughter right now, but maybe next time. Yeah.
Okay, because yeah, you have also very good experience for Databricks, so maybe you eventually can run something for us.
I do. I'm exploring right now the local development because they have Databricks Cluster bundles. And yeah, there is it's more fun to do. Even running the test that you're talking about. Actually, haven't done it, but I've seen videos. Databricks pushing a lot the local development.
Yeah. Okay, I will share the video and links to what Dmitry built, so maybe you can watch and ask more questions or provide some insights how you do this.
Sounds good.
Yeah, I think it was very productive. Yeah. It might be complicated, but that's why we have all the code. So you can run it everything yourself. You even don't need the Databricks to build the wheel package.
I actually
Thank
do have
you.
a question about wheels, but I haven't heard part of the conversation. The only thing is right now we can build the modules since the workspace support the files, and we can build Python modules inside of the repos and workspace. So I understand that Python wheels used to be sort of a workaround how to use the modules inside of the Databricks. You can attach them to cluster and such. So I was wondering, how does this right now have? Is it an actual thing still, Python wheel, or is it just something that people used to use and then they still use it just because it's like legacy? Well, I might be wrong. I'm just trying to explore the wheels as well.
Yeah, I haven't heard of these modules in the workspace yet, but it's just from my experience on my 3 previous projects with Databricks. We used Python wheels. That's why I'm still using it in this project. But yeah, I would like to explore this native approach with modules in the workspace more.